Hi, sweeties. Welcome to day 5, and we're going to talk about this trig some more. So we're going to continue on with the practice that we did yesterday with finding the missing sides of a right triangle using trig functions. And we're still covering the same standards from yesterday. We're going to explain and use the relationships between sine and cosines of complementary angles. We're really not going to focus much on this, but we may hit it in the lesson some. We're going to understand that what the ratios are, and we are going to talk about using these ratios to solve problems. What you're going to learn today is how to use the trigonometric ratios to solve right triangle problems. You're going to label the sides of a right triangle, and you're going to use the trig ratios to solve those problems. I said that first. Okay, babies, let's keep it going. I'm not going to go through vocabulary as heavy in this one, but I am going to go ahead and remind you of these trig ratios. Sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tan equals tan theta equals opposite over adjacent. And our trig ratios, SOHCAHTOA is the acronym we can use, or you can use the one that I like, some old hood rat called another hood rat, taking off Adidas. That's the one we used in high school. And the trick here, guys, the funnier you make it, the more likely you're going to remember it. So I try to use things like that to help you to remember. So here's the ratio. Let me run over the circles one more time for you. If you need to use sine, then you're going to do sine theta equals opposite over hypotenuse. If you need to use cosine, then you get cosine theta equals adjacent over hypotenuse. And remember, you go and put your finger on the part you're trying to solve for. And tan, you're going to use tan theta as opposite over adjacent. And let me make this a little neater. Okay, where's the pen? Oh, there it goes. So let's do the tan one more time. Tan of theta is opposite over adjacent. Okay, and there we go. Let's go ahead and keep moving. Once again, you're going to need your calculator, so make sure you grab that. And if you don't have one, you can always get one online. So let's go ahead and go through this one. Where here, I'm going to go ahead and label my side. So I'm going to put my finger on the given angle. And I'm going to label these. I'm going to label these sides. The slanted side is always the hypotenuse. The side that the shape is touching, that's not the slanted side, is always the adjacent side from the angle. And the side that is not being touched is the opposite side. So the side that this shape is touching is the adjacent, the slanted side, and the opposite side is the one that the shape is not touching. So I labeled my sides, and what I'm looking for here is the side that I'm looking for and the side that I know. So that's opposite and hypotenuse. So I'm going to write my SOHCAHTOA up here to kind of help guide my thinking. And the one that matches here is sine. So I know that sine 63 should equal 16 over x. That's opposite over hypotenuse. So I'm going to draw my circle in here, and this circle is going to help me to solve this. So I'm going to put my sine of 63 in this circle, and then I'm going to put my opposite up here, and then my hypotenuse goes here, which is x. And I'm going to put my finger, and I'm going to use a star. So you guys, I'm going to put the star right here, so I know that's the part I'm trying to find. And y'all, I'm going to figure out how to put these pictures on top. I'll get it right the next video. So I'm trying to solve this side right here. Let me see if I can bring it to the front now. No, not quite. Won't let me bring it to the front. But okay, I'll figure it out later. So you want to put your finger here because this is what you're trying to solve for. And you get 16. This ends up being 16 over sine of 63. And that is what x should equal. That's what our x should give us. So you grab your calculator. If you have a scientific one, then you can go ahead and find your fraction key. And your fraction key should look very similar like mine. What I pushed was alpha y equals to get alpha y equals to get what I needed for the fraction key. So I get 16 over sine of 63 here. Close that up. And make sure when you put in an angle in that you close this up. And you're going to put equals 17.93. And so therefore, this hypotenuse side, x equals 17 point, and it said round to the nearest tenth. So let me go look. That's going to be 17 point, that 5 makes this 9 go up. And then this 9 is going to make this 17 round up to 18. So therefore the answer is 18. And it didn't give us any units, so I'm just going to say 18 units. And we're done. Now, what's the difference between what we did in day 2 and now? Is that we don't have 3 sides here, or we don't have 2 sides. So I can't use Pythagorean's theorem. I was given 2 sides and an angle. So I have to lean on trig. And that's the biggest difference. Now, once you get this side, the 18, you can go and use Pythagorean's theorem to find the adjacent side. And let's see what we got planned in here. And okay, guys, so go ahead, finish up the rest of these problems on your worksheet. And then we'll talk about things in class tomorrow. We'll talk about these and we'll talk about the homework in class. I hope this has been helpful to you. That's the wrap up for this week. Monday will be a regular class. We'll do everything in class. And then Monday, your homework will be watch Tuesday's video. And then we'll keep this thing going. And I hope this is helpful. Please give me some comments. Let me know what's up so I can continue to make these videos better. Tell me what your needs are and I'll make them better for you. Bye. And remember, y'all roar. Be responsible, organized, accountable, and respectful, babies. Bye-bye.